10. Chapter 10 is our final chapter. And in chapter 10, we only have 4 lessons, which most of our chapters have only been 4 to 5, but this one only has 4. So it'll just take us through this week and then we'll be all done. Now, chapter 10 is also talking about radicals. So remember what we've seen with a radical. A radical is that square root. So we're going to be looking at square roots and we're going to be looking at cube roots, but we're going to be looking at a little bit more about what does their graph look like and how do we solve some of them. So that's kind of the last piece that they're going to dive into here, okay? So in 10.1, we're really going to be trying to just dive into what does really this square root really look like? So sometimes when you hear the word function is just another word for equation. See how they write it in function notation? That's the same thing if we were just to say y equals. So don't let that function notation bother you. But notice these words here, domain and range. And so with domain and range, they want you to take a look at the graph. So just to start off here, I'm just going to grab my graphing calculator and I'm going to go to the y equals and I'm just going to go ahead and type in the square root of x. And then I'll go ahead and hit graph. And let's just see what the graph looks like. Do you notice how the graph is starting at the center and then it's just kind of curving up like that to the right? So let me just draw you a quick sketch here. So it's starting right there at the origin and then it's just kind of curving up to the right like this. So now what they want us to think about is what is the domain? What are the possible x values? So let's take a look at this. The x values starts at, 0, 0. And then notice it's 1, it's 2, it's 3, it's 4, it's 10. Do you see how it's just going to keep going and going and going and going? So we start at 0 and we basically just get bigger and bigger and bigger and bigger. And so if we were in class, I would be asking you, how do you think I should write this? And hopefully you're thinking to yourself an inequality. X is greater than or equal to 0. And now let's take a look at the range. So the range is your y values. So your y value is starting at 0. And then notice maybe a half, it's 1, 1.5. Now it almost kind of in a way looks in this graph a little bit like it starts to kind of flatten out. But what I want to show you is if we go to the table, notice as x gets bigger, do you see how the y's are still getting bigger? They're just not getting big as quickly. Like, do you notice there's a 2? So there's 1, 2, 3, 4, 5 2's. We got 2, 2.2, 2.4, 2. We've got 5 of them before we get to a 3. So do you see how the y values are just going up slower? But notice you're at 3. Now we go to 4. Notice when x is 20, we're only at like 4.5. So the y's are taking their sweet time, but they're still continuing to go up. So for our range, we would say y is greater than or equal to 0 as well. Now these two numbers do not always have to be the same. They can be, but they don't have to be. So that's just kind of the equation. Now this right here is what we again call the parent. So this is what we call the parent function that we will be comparing to. So we saw this in chapter 8 when we did parabolas. So remember when we had these x squareds and then they would do something like x squared plus 3 and then you had to describe what this did to the graph. You're basically going to do the same thing, only now your graph is a square root instead of a parabola. Okay, and you'll see how these two kind of come together at the very end in 10.4. So this chart right here is actually fantastic. If you remember, we kind of made our own in chapter 8 where we talked about the different like horizontal translation, vertical translations, stretches and shrinks. So this is a really good chart and I just took this right out of the 10.1. So if you have a book at home, because maybe you checked one out or you want to go online, or you can look at my original copy of my notes here. But the one thing I really just want to make sure that we point out is if you're underneath the radical, So if you're under, notice you do the opposite. So see how it's a -2? That really moves it right 2. See how this is a +3? That really goes left 3. So notice anything under is going to be a horizontal. Just like down here, anything under, because it's multiplication, it's still a horizontal, but it's a stretch or shrink. So we've had these before. So anything under, so how about we say horizontal is under the radical, okay? So just kind of remember that. And then anything outside, notice how this is a +7 and a -1. See how it's outside? And then notice down here, see the multiplication is outside. So anything that's outside is going to be under our vertical. So outside like this instead of underneath like that, okay? And so I think verticals are a little easier because if you see a +7, then that goes up. And if you see a minus, it goes down. And so same thing with stretches and shrinks. If it's greater than 1, it's a stretch. If it's less than, so if it's between 0 and 1, it's a shrink. But horizontals, remember, you have to use the reciprocal. So just remember that. And I wish we were in class and we had a little bit more time because we could do a little exploration about why this is. But right now we just kind of don't have a lot of time. So a lot of it has to do of which axis it's being pulled towards. So see how this is the y-axis and see how this one is the x-axis. So a lot of it has to do which way the graph is being pulled towards. But just remember, if it's under, you have to use the reciprocal. So you can kind of see this looks like a 3, but it's really a 1/3, okay? So this chart is extremely helpful, and I definitely think you might want to have it handy to use as a reference. And so in today's lesson, we really only have one type of problem. They're going to give you an equation, and they want you to compare it to the parent. So they want you to graph it, compare it, and state the domain and range, okay? Now notice there are no graphs on here, and that's okay. We can just do like a rough sketch like this. It doesn't have to have all the little tick marks and things like that, okay? So if you're a little unsure because you're like, oh, this is the first time I've seen this graph, let's just go back to our y equals, and then let's just type this in. So let's just say +4. Now just make sure that you're underneath the radical, like how my bar kept going. And then let's go ahead and hit graph. Now, well, actually, before I hit graph, notice it's under. See how it's under? So I know it's going to be this one. And see how it's a plus? That means it's going to go left. So before I even hit graph, I already know which way it's going. So notice how it moved left 4. So on my graph, I'm just going to go 1, 2, 3, 4. I'm going to put my dot, and then I'm going to kind of curve it. Don't worry too much about this. Just kind of make it a nice curve. I'm not going to put a protractor on or anything like that. We're just kind of trying to get an idea of what it looks like. Now, for your comparison, you need to pick these words up here. Sometimes they call it a transformation. Transformation and comparison are really the same thing. Okay, so when you hear them say comparison, they want you to say horizontally left 4. That's what they want you to say. And I'm getting that right from here. So see how it's a horizontal translation. And then it moved left 4. And now if we look at our domain, notice it's starting at -4 and it's getting bigger. So it's going -4, -1, 2, 7. It's getting bigger. So we're going to say x is greater than or equal to -4. Yes, you will always have the bar underneath, but you may not always be going as the greater than. We'll talk about that in a minute. Now be careful with the range. This point is -4, 0, which means that the range starts at 0 and it's getting bigger. Remember, it's getting bigger slowly, but it is getting bigger. So our range is y is greater than or equal to 0. Now notice our numbers do not match, and that's okay. That's probably more common to see, okay? So if you want to pause it and maybe give these two a try, I don't want you to try all of them right off the bat, because if you were to make a mistake, I wouldn't want you to get stuck. So if you'd like to pause it here, you can. All right, number 2. Notice that the only thing they're doing is it's the plus 5, and notice it's outside of the radical. So what I'm going to do is I'm going to move up, 1, 2, 3, 4, 5. So there's my point, and then I'm just going to kind of do the same curve, okay? So this is really 0, 5. Sometimes it helps to write that down for when you go to do your domain and range, okay? Now notice this is outside. So if we go back up here to our chart, notice when it's outside, then that's a vertical translation. So we're going to say vertically translation up 5. Now let's do our domain. Our domain is always our x's. If we look at this, notice it starts at 0, that's our x, and it's getting bigger. So we're going to say greater than or equal to 0. And then notice this one is our range. This is our y. So it starts at 5 and it's getting bigger each time. So we would say greater than or equal to 5. All right, let's take a look at number 3. Now, number 3, the negative is outside. And if you look at your chart, you can see what it does up here. But if you want, let's just quick type this one into our calculator and let's just get a good visual. Sometimes it really helps to type these into your calculator a few times, just so you get a kind of an idea of what they're going to look like, okay? So let's see, notice it's down at -2, and notice it's going the other way, okay? So let me show you something here. Here was the parent. Here's the parent, that's the square root of x. They told us to do a negative first. So what a negative is going to do is it's going to reflect it. So it's going to make it go down this way, like that. That's the negative square root of x. Now this -2 is going to take this point and go down 1, 2. And so now we have this point down here and it still has this shape to it. So it looks like that. Okay, so let's write down this ordered pair, 0, -2. That will help us again do our domain and range. So let's start up here at our comparison. Remember, this is the original, so they've added on a negative. So a negative on the outside is a reflection over the x-axis. You got to be really specific on this one. So reflection over the x-axis. And then notice we now have 2 things because we also moved down 2. So we would say vertically translation down 2. And please make sure you're using the correct vocabulary here. Okay, we've got our domain and our range. So our domain, we're starting at 0 and we're still getting bigger even though the curve is going like that. It's still 0, it's 1, it's 2, it's 3, it's 10. It's still getting bigger. So we're going to say greater than or equal to 0. Now we got to look at our y's. Our y's are at -2. That's the highest y. But notice they're going down. So it's -2, -3, -4. They're going down. So this time we need to change our symbol. And then we say -2. So this is really what the whole lesson is about, is it's taking this square root shape and it's doing the different transformations. So I told you there's only 6 problems, and so you can see there's 3 more right here, and they're just a little bit more complicated. And so I would really love it if you would pause this and try it on your own. All right, number 4. Number 4, the first thing I'm noticing is this negative is under. So I'm going to go ahead and just actually write that down. The negative under is a reflection over the y-axis. And if you need to, you can refer back to your chart here. But notice when the negative is under, it's a reflection over the y-axis instead of the x. So our original looked like this. This was the original. And now we're going to shift it this way. That's the negative that's under. Now this is also under. So we know that's going to be horizontal because it's under. But let's take a look and see what it does to the graph, because that's kind of a unique one. So we know it's going to flip and go this way. But do you see how it almost kind of flattens? Let me add in here a negative parent, just so we can kind of see the comparison. So do you see how this is the parent? Do you see how it's a little flatter? So what I would do with your graph is I would just draw it a little flatter. Again, I'm not going to put a protractor on this and say, oh, it's too flat or it's not enough, but just draw it flatter so that we have something to compare to. So we know this is going to be a horizontal. Now be careful. With horizontals, remember, we have to do the reciprocal. So see how this was a 1/2? So we call that a stretch, and then we use the reciprocal. So horizontals, stretches and shrinks, can be a little tricky. So this is a horizontal stretch of 2. You got to watch those reciprocals. And so again, if we take a look at this point, this is 0, 0 still. This is our starting point. So we're going to have x. Now notice the x's are getting smaller this time. So we have 0, we have -1, we have -2. Our x's are getting smaller. Now take a look at your y's. The y's are starting at 0, but they're still getting bigger as we go up the graph. Now they're just going to be slow, but they are getting bigger. So again, if it helps you to type these into your y equals to kind of get a comparison, please feel free to do so, okay? All right, so let's start here, the 1/2. The 1/2 is outside, so that's going to be a vertical shrink of 1/2. And again, please reference the chart if you're not sure. See how it's outside and it's a shrink? And then we just use the number. We don't have to do the reciprocals when it's outside. Only when it's under do we do the reciprocals, okay? So this is just going to make it a little flatter. So again, it's just going to kind of be flatter. And then here I can kind of draw it. So here was your parent. And now the 1/2 is just going to make it flatter like that, okay? Underneath, you got to be careful. We know that's going to be horizontal, but it's the opposite. So it's going to go left 2. So now it's going to take this and shift it left. So right here and then flatter. So hopefully you can see it's a little darker. I tried to draw that a little darker. Then this is outside. Outside is always vertical. So we're going to go vertically translation, and it just is what it is. Down 2. So we're going to go right from this location, right here. We're going to go down 1, 2, and that's our new spot. So let me draw this in red so we can see the final answer. There's our final answer. And so let's also put the ordered pair here. That would be -2, -2. So my domain is going to be x is at -2, and notice it's getting bigger. Okay, so we say greater than or equal to -2. My y's are also at -2, and they're also getting bigger. So y is greater than or equal to -2. So notice that one, they are the same, but they don't have a 0 involved. Okay? All right, our very last one. And if you'd like to pause it here, you're more than welcome to. This one has a lot going on. If we start with the parent, there's the parent. Let's just take it piece by piece. Let's go with the negative. Now remember, the negative on the outside is going to reflect it over the x. So there's the negative on the outside. So let's say a reflection over the x-axis. Notice we have a 2 on the outside, just like over here. But do you see how this was a fraction? That makes it flatter, and it's called a shrink. Do you see how this is a whole number? So we call that a vertical stretch. TCH, stretch of 2. Sorry, I kind of drew a blank for a minute. So all that's going to do, that's going to take this graph, and it's just going to make it taller, steeper, like that. So that's our -2. All right, so we don't really have these ones anymore. These ones kind of gone now. -3 is underneath. I'm just going to scribble this out for a second. We'll just kind of move it down. I didn't leave myself a lot of room here. So -3. The -3 is under, so we know that's horizontal. And remember, under is always the opposite. So if this looks negative, it's going to go positive. So it's going to take this dot and go 1, 2, 3 this way. So it's going to start right here, and then it's going to go down. Okay, so this is our graph now. So this one's gone. So that's going to go right 3. All right, let's do our final move here. Plus 1. So we're going to take this dot and we're just going to move up 1. Boom. So now it kind of looks like that. So that would be our final graph. Okay? So we're going to say vertically up 1. And now we just have to do our domain and range. Let's go ahead and write down this ordered pair though, just so we don't lose track. Here, we went 1, 2, 3, so we went right 3, and we went up 1. So there's our ordered pair. So our domain is our x's. So we know it's going to be the 3. So we just have to look at the x's and ask ourselves, is it getting bigger or is it getting smaller? So this would be 3, this would be 4, 5, 6. So we know it's getting bigger. And now let's take a look at our y's. We know the y is going to be 1 because we can see it right there. So we take this number 1 and we look, are our y's getting bigger or are they getting smaller? And if you kind of just take your pencil or pen and kind of trace the graph, you'll see how it's going down. So we know they're getting smaller, okay? And so that concludes lesson for 10-1. Remember, to 10-1, we just did the square roots. And in 10-2, we're going to take a look at the cube roots. So it's very similar to what we just finished with chapter 9.